Okay, so I'm going to record the answers to written assignment number 2 for you. Okay, this has got a lot of the information that we covered in section 1.3. All right, so when you're doing these problems with linear velocity and angular velocity, it's always good when you read the problem to kind of write down what you're given. So when I read this, it says a satellite in circular orbit. It's a certain amount above the Earth, and it makes one complete orbit every 86.55 meters or minutes. Okay, so what that means is that is an angular velocity. Okay, and remember the variable we use is omega, and if I write that down, an orbit is a revolution. So we're really saying one revolution per 86.55 minutes. So that is a revolution per minute. That's a unit that we have for angular velocity. Okay, and let's see. We're going to use this for the Earth. We have that it's 816.5 miles above the Earth. So the next thing I'm going to do is I'm going to draw a picture of the Earth. Okay, so here's the Earth, and we have the center of the Earth, and it looks like you're given the radius of that Earth is 3,963 miles. And then the other thing, I'm not going to draw this to scale, but you also have the satellite is traveling around the Earth, and this distance above the Earth is, what is that, 816.5 miles, okay? So what you really are going to have on this when you start putting this together is the radius that we're going to use in our computation is going to be these two things added together. So we're going to need to take 3,963 miles plus 816.5 miles and put that together. So I'm going to take my calculator and get that together, and then we'll kind of talk about what we're trying to find in the problem. So we got 3,963 plus 816.5, and that's going to give a radius of 4,779.5 miles. Okay, so that's what we're given. Really in this problem, you're given the angular velocity and you're given the radius. Now what you're trying to do on this, the next thing is, what are you trying to find? So what we're trying to find is the linear velocity. Okay, that's what the question is, what is its linear velocity? So we're trying to find the linear velocity. Okay, we have a formula that is V equals R omega. So we have everything we need. Now, the first thing that you want to do in this is, I'm going to go ahead and put this in the formula. So we're going to use 4,779.5 miles. But then our angular velocity needs to be converted to radians per minute. So I'm going to go ahead and put this in here. So we have one revolution takes place in 86.55 minutes. That's a pretty fast satellite. Okay, and what we're going to do is we're going to multiply that by the connection between revolutions and radians, because this needs to be in radians per minute. So we know that one revolution is 2 pi radians. Okay, now if you look at this, excuse me, what happens is revolutions cross out, and you end up with miles per minute. If you look at your answer choices, they're all in miles per minute. And remember, we said radians is really unitless. It's more of a placeholder. So all you should have to do on this problem then is go straight to your calculator. I'll show you how you want to put that in your calculator. So let me move this over the side so you can see this okay. Okay, so I'm just going to put in exactly like this. The radius is 4,779.5. And we're going to multiply that by 2 pi. I'm multiplying the numerator straight across. Okay, and I'm going to get that answer. And then I'm going to divide by 86.55. And we'll round it, and then we'll see what we get. Okay, so it looks like I'm getting approximately 346.972, and then some other decimals on that. So I think we're only going to round that to the whole, maybe the whole number. So it looks like the closest answer choice would be B. Okay, and again, that's going to be in miles per hour. So that's how you want to do that problem. Okay, next problem. Let's see. Again, we're going to kind of look at the same thing. It's a good idea to write down what you're given and then what you're going to try to find. So this says you have a gear. Okay, so we have a gear that has a radius of 32 centimeters. Okay, so that's an important part of these problems is we have a radius, so that's centimeters. Okay, then it says, I keep sneezing. Sorry, I had to pause so I could sneeze a couple of times. I don't want you to hear me sneezing during my lecture. Okay, so the next thing is we have this. Now see, that is an angular velocity because of the units. The units are in radians per second, so we know that that's omega. That's an angular velocity. So we'll write that down as pi over 11 radians per second. Okay, and that appears to be all we have. And then the next thing is you're trying to find the linear speed at a point on the outer edge of the gear. So what we should have to do on that is we're going to find the linear velocity, so we're going to find v. Okay, so really all we got to do is we have the formula just like the last problem, r omega. The radius is in centimeters. Notice that our answers have centimeters in it. So we're going to go 32 centimeters, and then we're going to multiply by the angular velocity, which is pi over 11. All the answers have pi in it, so it looks like when you crunch that out, you're going to get 32 pi over, whoops, wrote that wrong, 32 pi over 11. And again, when I put the units in there for angular velocity, I've got radians per second. Radians is kind of dimensionless, so we have centimeters per second. So that appears to match up with choice C. Okay, so the answer to this page, you should have had B and C. That's the way your work should look on those problems. Okay, going to the next problem. Now, this is one that I went through in my lecture, and this one is kind of a longer problem. So we want to kind of look at this. This says you have two pulleys that have a diameter of 6 and 3 that are connected by a belt. The larger pulley rotates at 39 times per minute. We're going to find the angular velocity of the smaller pulley. So the way I'm going to approach this at the beginning is I'm going to draw a diagram. So the first thing I have is I have a larger circle, and that diameter, the diameter of that circle is 6 meters. So that means that the radius, which is half of that, the radius would be 3 meters. Okay, so we have that. Then we have the smaller circle. Oh, I didn't mean to do that. Okay, the smaller circle has a smaller diameter, so I'm just going to move that down and kind of label that. This one has a diameter, it looks like, of 3 meters. So again, the diameter is all the way across the circle. So the radius would be half of that. The radius of that would be 1.5 meters. Okay, so the way I'm going to kind of write this is I'm writing down my given information. What I've got so far is I've really got this. I've got the radius of the large, and I'm going to write this as radius of L for radius of large circle. That is 3 meters. Then I've also got the radius of the small circle is 1.5 meters. So that's what I've got so far in the problem. Now, if I look at this, it says the larger pulley rotates at 39 times per minute. So again, that is an angular velocity. And it's an angular velocity because it's given revolutions per minute. So I'm going to write this down as the angular velocity of the large pulley. And it says it does 39 revolutions per minute. Okay, that's what it's implying by the way that's stated. Okay, so that's what we've got so far. Now what we're trying to find is we're trying to ultimately find the angular velocity of the smaller pulley. So that's what we got. So this is always an excellent approach to these problems, is to write down what you're given, identify what you're trying to find, and then kind of think through the formulas that you got to use. Well, one of the things that we talked about in my lecture is the linear velocity of these two circles is going to be the same. So what we know is we know this. We know the linear velocity of the large pulley is the same as the linear velocity of the small. And what we can do on this is we could go ahead right now and we could find the linear velocity of the large because we have enough information. So the first thing I'm going to do on this is we have the formula, the linear velocity of the large is equal to the radius of the large times the angular velocity of the large. Okay, and again, we're going to have to change that to radians per minute, and I'm going to go ahead and just do that in one step. So we're going to take the radius, which is 3 meters. We're going to multiply that by the angular velocity, which is 39 revolutions per minute. But what we want is, you notice we need to change this into radians, okay, or the revolutions needs to go into radians. So what I'm going to do is we know that 1 revolution is the same as 2 pi radians. Okay, and if you do that, the revolutions cross out. Radians is unitless, so now we're in meters per minute, which is what we would expect for a linear velocity. It's a distance over a time. So I'm going to take my calculator, and I'm going to go ahead and crunch that piece out. So I'm just going to go straight across. 3 times 39 times 2, and see they're leaving pi in their answer, so I'm just going to leave pi in the answer. So that's going to give 234 pi radians, or not radians, meters per minute. Okay, so that would give us this then. So we have meters per minute there. Okay, so we've now got that figured out. 234 pi meters per minute. Okay, now the next thing we're going to do is, since we know this, next thing is we know the linear velocity of the small is also the same. That's kind of the key to the problem. So we have that. So now what we know is the linear velocity of the small is 234 pi meters per minute. Okay, so to finish up the problem then, all we should really have to do is apply this formula. We know that the linear velocity of the small is the radius of the small times the angular velocity of the small. Okay, now I need to just solve this equation for the angular velocity. So what I'm going to do is just divide both sides by the radius. And then that will leave us what we ultimately need to do is the angular velocity that we're trying to find is the linear velocity divided by the radius. And we now know those two things. So notice the linear velocity is 234 pi meters per minute. Let me write that a little better. Yeah, so that's 234 pi meters per minute. Okay, and then the radius was right here, 1.5 meters. Okay, so what you're going to end up having is these meters are going to cross out, and you're going to end up really with radians per minute. So all I need to do is just take 234 and divide that by 1.5, and then that will give 156. Okay, so it looks like the answer to the problem would be 156 pi radians per minute. Okay, so that would be the final answer. So that looks like that is going to be choice D on this problem. That's how you work that out. We looked at that in the lecture. If you look at your notes, we went over that same kind of problem. Okay, the next problem. Now remember, you can pause your video at any time if you want to look over these and go through these. Number 4, we're going to take the same approach. Let's see, let's start off with what we're given. So it says we have a truck is fitted with new tires, and the tires have a diameter of 41 inches. Okay, and remember the radius is half of that. So you can take half of that in your head or your calculator. That'd be 20.5 inches. You want to use radius because that's what's in your formula. Okay, now it says, how fast will the pickup truck be moving when the wheels are rotating at 430 revolutions per minute? Okay, so you got to know what this is. See, this is an angular velocity because it's in revolutions per minute. So that means that our angular velocity is 430 revolutions per minute. Okay, so that's what we have on the problem. Now what we're trying to find if you read the problem, we're trying to find how fast the truck will be moving, and that's really implying that we're looking for a linear velocity, which is v, and the formula is v equals r omega. Okay, so we already have r and we have omega. We need to pay attention to the units. So the radius is 20.5 inches, like that, and then the omega is 430 revolutions per minute. Now, if you look at your answer choices, they are all in miles per hour. So we actually have quite a bit of unit conversions we got to do. And you can do this all in one step the way I'm going to show you if you want to. So what I'm going to do is I'm going to start by working on this revolutions per minute. I need to change that to radians. So we have in one revolution, we have 2 pi radians. Okay, we don't want revolutions as a part of our answer. We want miles per hour. Okay, so and remember, radians is really dimensionless. So right now we're in inches per minute. So the next thing is we need to convert the inches to miles. Well, what I know is there are 12 inches in 1 foot. Okay, that will cross that out. Now my answer is feet per minute. And then I also know that there are 5,280 feet in 1 mile. Okay, so now my answer is in miles per minute. And then I need to convert the minutes to hours. So we know there are 60 minutes in 1 hour. Okay, so you got to do all these conversions on this. And then if you begin to look at this, okay, what we ended up with is we ended up with miles per hour. So we've done all our conversions right. Now what you got to do is you got to really do this correctly on your calculator. And you got to be really careful about how you do this too. Just kind of a general rule of thumb is go straight across. See, these things could be put over 1 and go straight across. Do the numerator. So you have 20.5 like that times 430. And times 2 pi, I'm just going to put the pi key in like that, and then times 60. Okay, and then I'm just going to record that. You don't have to write that down, but I'm going to write that down. That is, looks like 3323176.709. And then I'm going to go through and do the denominator. So the denominator is just 12 times 5280. Okay, like that. So I'm going to record that as 63360. And again, that's in miles per hour. And then I should get my answer if I just divide those two numbers. So I'm going to go 332.3176.709. And then I'm going to divide that by 63,360. Okay, and if I do that, I should have about 52.5 miles per hour. Let's see which answer choice is closest. And they wanted a nearest whole number, so I guess on that one it would be the 52. Even though that would round up to 53, some of these things can be off a little bit because of how you round. Okay, so the answer to that one is going to be B. Okay, so this page you should have got D and B as your answers. That's the way that you should have worked those out. Okay, going to the next page. Let's see. Now this one says you have a satellite that orbits around the Earth at a distance above the Earth's surface of this many miles. So that's the amount above the surface. Okay, it says 1 revolution around the Earth takes 10.6 days. And see what that is that is an angular velocity. So that's omega. Then we have the radius of the Earth is 3960 miles, and then we're trying to find the linear speed. Okay, so I'm going to start by drawing a picture on this problem. So this will be Earth. And one of the things it says is it has a radius that is equal to 3960 miles, so that's a given. We also have the satellite is above the Earth in orbit, and I'm not going to draw this to scale, but that distance right there is going to be 2.6 times 10 to the 4th miles. And then the satellite's going around Earth, So we have that. Okay, so when we start kind of writing down our given information, really what we have is we have an angular velocity. Okay, and that angular velocity says 1 revolution takes 10.6 days. So that's what that is. Okay. And the other thing we have is we have the radius. Now the radius would be these two things added up. So you would have 3960 miles plus 2.6 times 10 to the 4th miles. Like this, you need to take your calculator and add those things up. So one thing that's kind of important on this is you could look at this. Let me just kind of move this over here. This is scientific notation. So if you have 2.6 times 10 to the 4th, that just means the decimal gets moved over 1, 2, 3, 4 places. So you would actually have 26,000 miles. Okay, is what that would be then. Okay. Now you can put it in your calculator in scientific notation if you want to. So you could go 3960, and then you could either put in the 26,000, okay, like that. That seems like a really big number to me, but that's okay. These things are both in, make sure they're both in miles, so that's okay. And then I can go plus 2.6. Then you have this EE key. That's how you put scientific notation in, and that's to the 4th. And that will give you that answer in standard notation, so that's going to be miles like that. Okay. So what we're going to try to find on this problem then is we're trying to find the linear velocity. So we got to put this together. We got a bunch of units to convert. So the basic idea with this is linear velocity is r omega. We have the radius. The radius is 29,960 miles. Okay, we have the angular velocity is 1 revolution in 10.6 days. Okay, now we have a bunch of unit conversions to do. We need to change the revolutions to radians. So we're going to go ahead and multiply in 1 revolution. There is 2 pi radians. Okay, so that's going to cancel that out. Okay, and remember, radians is unitless. So right now, your answer is in miles per day. We want miles per hour. Okay, so we can do this. We know that in 1 day, there are 24 hours. Okay, so now if you look at this, what we're left with is miles per hour. Just got to go to the calculator and do this correctly. Now I'm going to do this all in one step this time. You want to learn how to just use your parenthesis keys on the calculator. So if I do this, what I'm going to end up having, see, I can do, the numerator is 29,960 times 2 pi, and that's it. Okay, so I can just put a parenthesis there. So see, that'll give the numerator, then divided by a new parenthesis. Now the denominator is going to be 10.6, and then times 24. Okay, like that. Okay, so I can go ahead and just crunch that out. So that's giving about 739.95 miles per hour. So that appears to match up with choice D if you round that to a whole number. Okay, so that's how you would do that problem. Okay, next problem. We're looking at finding the values of the 6 trig functions. Okay, and what we'll have on this then is, if you're given a point, really what you need to show me on this is that you've been given x is -2. You've been given y is -5, so you have to find r. So you must find r, and you do that by the formula x squared plus y squared equals r squared. That's the Pythagorean Theorem. So you'd have -2 squared plus -5 squared equals r squared. So that's 4 plus 25 equals r squared. I'll move this over here, and I'll get 29 equals r squared. Now we do the square root of both sides, so we get r is root 29. You know, and technically you have a plus or minus there, but the radius is always positive. So we have radius is square root of 29. Okay, now it's just a matter of applying your definition. So the sign is y over r. Okay, The cosine is x over r. The tangent's y over x, and then you can do the reciprocals as you go. So the sine is going to be negative 5 over root 29. You can go ahead and do the reciprocal of that and get the answer to the cosecant, which is negative root 29 over 5. So that gives us our first trig function. You want to go ahead and rationalize the denominator, like we've learned how to do. So the answer to that problem would then be negative 5 times square root of 29 all over 29. You've got to rationalize denominators on these problems. Okay, the next one is the cosine. The cosine's x over r, so x is negative 2, r is root 29. You can go ahead and do the reciprocal now and get the secant. So the secant would be negative root 29 over 2. And that would take care of your answer there. And then we need rationalize the denominator. So I'm going to multiply by root 29 over root 29. And then the final answer to the cosine would be negative 2 root 29 over 29. Okay, and that leaves us with the tangent and cotangent. So the tangent is y over x. That would be negative 5 over negative 2. That's 2/5. And then the cotangent's the reciprocal of the tangent. So that would be 5/2. So those should be the answers that you get on that particular problem. Okay, next thing we're going to look at is just finding some exact values of some expressions. You want to try to do this. Just think about what these things are with your definitions on a circle. So if you look at a couple of things on this, the first thing I want to show you is if you're at 360 degrees, that's one lap around the circle. So you're at the point 1, 0. If you just let r be 1, then you can figure that out, okay? And then 90 degrees, you would be here, and that would be the point 0, 1, okay? So here's kind of what we know in the problem. If you're doing the cosine of 360 degrees minus 3 times the sine of 90 degrees, well, what we have is this. If you go to the cosine of 360, that's just x over r. If you go to the sine of 90, the sine is y over r. Okay, so in this problem, if you look at 360 degrees, x is 1. We let r be 1, so the cosine of 360 is 1. Then we go to 90 degrees. See, the sine is the y value. Okay, that's y is 1. So we'd have 1 over 1 like that. So what you'd have is 1 minus 3 times 1 equals 1 minus 3. So the answer to that problem should be negative 2. Okay, so those should be the answers that you get on that page then, okay? Right, moving to the last page here. Okay, we're going to figure out the sine of pi over 3 minus pi over 6. Now what I'm going to do on this problem is I'm just going to get a common denominator. You could also convert this to degrees now if you want to. It doesn't really make any difference which way you do this. I think I'll do it this way. I'm just going to change these to degrees. So remember, we know pi is 180 degrees. So we would have 180 degrees over 3 minus 180 degrees over 6. So that would give the sine of 60 degrees minus 30 degrees. So that would give the sine of 30 degrees. Okay. Now what we need to do is just kind of look at our triangle. So we are in quadrant 1. So what you'd want to do is just kind of sketch out your angle in standard position. So a 30-degree angle is in quadrant 1. Okay, so what I would have here when I do this is that would be 30. Again, your reference triangle goes straight down to the x-axis. That angle would have to be 60. And remember, the sides go like this. On a 30-60 right triangle, the sides go 1, 2, square root of 3. And it's logical. 1 is the smallest number. 30 is the smallest angle. So the 1 goes there. And see, that would be a y value because it's how far up you are. X would be the square root of 3 because, you know, square root of 3 is about 1.7. So that goes opposite 60. And that would give the x value. And then r would be 2. So you'd be ready to get your answer to your problem then. So see, the sine's y over r. So in this diagram, y would be 1, r would be 2. So the answer to that problem is 1/2. So what you have to do on that is you have to work with your special triangles. Okay. Look at the next one here. Is another one that deals with special triangles. So what I'm going to do is I'm just going to do this one this way. At the side, I'm going to draw out a 30-60 right triangle. And you can do this in several different ways if you want to. So if we're looking at 30 degrees on this, so if we're looking at the cosine of 30 degrees, so what we have is we have the cosine of 30 degrees multiplied by the sine of 60 degrees plus the sine of 30 degrees times the cosine of 60 degrees. You want to do this totally without your calculator. Well, the cosine's x over r. The sine is y over r. Again, sine's y over r, cosine's x over r. So that's what you ultimately have to do. Okay, so if you have a 30-degree angle in quadrant 1, this means y is going to be 1, x is going to be square root of 3, and r is going to be 2. Now we're interested at these two things. We're interested in the cosine and sine of 30 here. So if I do this, see, I can get this thing like this. The cosine would be x over r, so that would be square root of 3 over 2. Okay, and then the sine of 30 would be y over r, so that would be 1 over 2 like that. Okay, now what I'm going to do is I'm just going to look at the 60-degree angle. So if I look at a 60-degree angle in quadrant 1, it would look like this. Okay, that's going to be a 60-degree angle, 30-60 right triangle. The sides go like this. Opposite 30 is the x equals 1. Opposite 60 is y equals square root of 3, and r is equal to 2. So in this diagram, what you would have is the sine of 60 would be y over r. So that should be square root of 3 over 2. Okay, and we got the plus, and then the cosine of 60 is 1 over 2. So we'd have this. And then this is what we need to work out then. So if you work this out, see, that would be 3 over 4. If you worked this out, that would be 1 over 4. So you got 4 over 4. So the answer is equal to 1. So the answer to that problem should be A is equal to 1. Okay, so you got special triangles is what you're doing. Okay, the next thing we're going to do is just use a calculator to finish up here. So I'm going to show you how you would do this on your calculator. Okay, so we're going to do the cosine of 601 degrees. You want to make sure if you press your mode button that you're in degree mode. And then it's pretty simple. Just go cosine of 601 degrees. And then we'll round that off. I think you want to round it to 4 decimals according to this. Okay, I'm going to pull this over here just kind of for reference. Okay, and that would be kind of what we have there for that answer. Okay, and if we round that to 4 decimals, let's see, that looks like that would be negative 0.4848. So let's see if we have that. That would be clearly choice D on that one. Okay, next one we're going to do this. There's 2 ways you can do this. So you can do this like this if you want to. You could go sine of 55 degrees. Now you can go second apse to get the angle to come up. Then you have a degree symbol. Then you put in the 50. So you can go 50 minutes. So again, second apse. Okay, like that. And then get the minute to come up. And then you can press enter. Okay, and then that's what you would get for this one then. So I'm going to slide this over here so you can see this. Okay, so if you round this one to 4 decimals, it looks like that would be 0.8274. So that would be choice C. Okay, you could also do this problem like this if you wanted to. You could also go like this. You could go sine of 55 plus 50 out of 60. That way you're changing this to a decimal degree like that. Okay, and then you can do it that way. Of course, you would get exactly the same answer. So it doesn't matter which way you do those. I usually do it the second way. I just find it a little quicker if I just go ahead and convert that the way I did there then. Okay, so that's how that would go. Okay, and the last problem, let's see. We're just going to put this in the calculator. You would put this in one step like this. You could go 1, and you'd have to do this in parentheses. That numerator has to be done first. So I'm going to go 1 plus sine of 37.6 degrees. Okay, then close the parentheses. So I got to double up on that parenthesis and then divide by 3. And be in degree mode, and then that should be how you would do that problem. You can pretty well just do that in one step on your calculator. If you round that to 4 decimals, that looks like 0.5367. So that looks like choice B. Okay. So in this on this page, you should have got the answers B and A, D, C, and B. Okay, so that'll close that off. Hopefully this helps you to get some feedback on your homework and learn from your mistakes.